Hey everyone, this is Sandip back with another video. And in today's video, I'm going to talk about Big O. A really big term, Big O, right? And because it's really important in terms of, cracking the interviews in the product-based company. So, I'm going to talk about Big O, and there will be some theory in this video, and we are going to see practically how why Big O is so important when you're writing any computer program or any function. So let's jump into the little bit of background around programming, right? If you're a programmer, or if you're learning programming, right, or if you're a seasoned programmer, right, you might be knowing, right, computer programs are like collection of data and functions. So given a statement, right? I mean, let's talk about this. Given a statement, a problem statement, I'll give you a problem statement, and there are like so many programmers in the world, right? Multiple programmers, right? So given a string as an input, return its reverse value, right? So maybe if I give you input as mom, right? The reverse of mom is mom, correct? So like there are two programmers or there are 10 different programmers, and if we have given a problem statement to solve this problem, those 10 programmers can come up with different solution, right? And how we are going to decide like which program is a good program and which program is a bad program. That's a difficult situation, right? Because take the example of two programmers, right? And programmer A is saying, hey, my program is good, a programmer B is saying my program is good, right? How we are going to satisfy their egos, maybe if I talk in that term. So I'm going to jump into Google, and we're going to search for JavaScript reverse string Stack Overflow solution. So on Stack Overflow, if you visit this link, there are multiple implementation of this particular problem statement. So if I scroll down, see that I got a implementation 1, that is reverse, and here we are using for loop. There is implementation 2, which is again for loop. And the join function is also getting used. Implementation 3 is again for loop, but this time implementation 4 is based on some of the JavaScript functions. And here you see some one of the programmer has used a while loop also, right? So as I said, I mean, there are multiple implementation of a particular function, right? And programming is all about data and functions. So as I said, multiple implementation of a single problem statement could exist, and multiple developers can come up with different solution. How we are going to decide, hey, which program is a good program, right? For that, we have something called Big O to help us, right? So maybe we can start with this idea, idea of a good code versus bad code. But good code and bad code is not at all important here. What is important, and we should talk in terms of something called a scalable code. And scale, if you don't know, I mean, if this term is new to you, right? What is scale in terms of what is a scalable code, right? So scalable in terms of time and space. I mean, if I've given an input, right, to a particular function, how fast that function is returning the output. And while I like take the example of this one, reversing a string, right? So here, given input s, how much time this reverse function is taking to return the reverse of a string. And while executing that code, right, how much space this particular program is taking. Because if you see here, right, we are creating different variables, we are using a while loop, and definitely it's going to take some space in the computer's memory. So we talk in terms of these two different terms, time and space. And based on the scalability, we can define either a program can be an excellent program, it can be a good program, it can be a fair, bad, or a horrible program. I'll go into the real world situation. Maybe we'll take the example of Amazon.n, right? And say, suppose I'm searching for iPhone here. And Amazon has big, I mean, more than crores of product, right? Product inventory, big product inventory. So say, suppose I have 10 products in Amazon inventory. Searching for iPhone is really easy job, right? Because I need to count from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's an easy job. And I'm going to get the iPhone somewhere in this particular numbers. But when we talk about crores or product, in that case, if I talk, if I count 1, 2, 3, 4, 5, 6, 7 up to crore, right? You're definitely going to leave this video right now. So when the scale, when the number is high, when the input is high, and if you're working at that bigger input, right, and the program is taking a lot of time. Maybe you're searching for iPhone today, and the results are coming. You're searching for iPhone today, and the results are coming tomorrow. You're going to leave Amazon.in straight away, and you will go to some other site, some other e-commerce site. That's correct, right? That's why we need to have a scalable code in terms of time and space, and based on that we can define, we can justify our code, we can rate it whether it is excellent, good, fair, bad, or horrible code, right? So let's jump into the practical example. I'm just going to go into my developer tool. So I'm going to just right click and inspect here, and I'm going to write all of my code inside the snippets. So there is a snippets tab. If you go into the sources inside your dev tool, I'm going to create a new snippet here, and I'm going to write a function called add up to num1. So there are two different. So think like, I'm behaving like two different programmers here. The first programmer is going to write the first implementation, and second programmer can have a second implementation. So here is the first implementation. So given a number, so this program is nothing but given a number, you're going to add all the numbers inside that function. So let me write the function and you'll get the idea. So function add up to num is going to take an input, maybe n as a number. And now say suppose I'm calling this function, right, with the input of 5. So what it's going to do, so 5, so it is going to add 1 plus 2. First of all, 0 plus 1 will be 1. Then it's going to add 1 with 2, so 1 plus 2 is 3, right? 0 plus 1, 1 plus 2 is 3. Then 3 plus 2 is 5, something like that. So forth, so on and so forth, right? Something like that. So that's what I want to write here. So first of all, I'm going to create a variable, say let sum is equals to 0. I'll start with sum 0. And this is the variable where I'm going to store my output, right? And I'm going to use for loop. Because in most of the programs, we use for loop. So let I is equals to 0, I less than n. So I'm going to run my loop till I is less than or equals to n, and I'm going to do the I plus plus. And here inside this, I'm just going to say sum plus equals to I. And finally, I'm going to return my sum. Now let's test this program. So I'm going to have this inside my test variable, and I'm going to console.log test. And let's see if our program is working. So I can click on this play button, or I can press Command Enter to run this program, and you see the output, right? 5. Say suppose we give it an input of 10 and run the program. It's giving the output of 55. Good, like the program is running, right? It's working fine. This is solution 1, and this is the input 1. Or I'm just giving a really small input. But before I give a big input, I want to write another implementation, which is like a second implementation for this program, where I'm going to use I just need to remember that formula actually. So I'm going to use a formula, right, to implement this particular solution. So I'm going to add a new snippet here. Add up to num. And this will be my second solution. So second programmer who is a smart programmer probably and coming up with the solutions. Function add up to num, which is going to take n as an input. And here again, I'm going to have let sum is equals to, this time I'm going to use a formula. So n into n plus 1. So someone has invented this formula, I don't know, and which is going to give us that same result what we were getting in this particular program, the first implementation. And here I'm going to return my sum. Okay, same function but different implementation. And I'm just going to steal some code from here, just to save time. So I'm going to copy this and paste it here, and now I'm going to run this program. I'm getting the same output. But let's look look at both of these programs, in terms of scale, right? So to do that, I'm going to use some of the built-in methods of JavaScript. So first one, I'm going to create some variable here, start time is equals to, I'm going to use my performance dot now method. This is built-in JavaScript function. So basically, it's going to give me the start time, the time right now in milliseconds, probably in the date format. And I'm going to just copy and paste this one, and I'm going to say end time. So just before running this function, I'm grabbing a snap of a time, and here after running this add up to num function, I am just having this snapshot of time, right? And finally, I'm going to use these two variables, these two constants, start time and end time, right? And I'm going to generate an expression. So I'm going to say elapsed time, and I'm just going to subtract the end time minus start time, and I'm going to divide this with 1000 because it's going to return me in milliseconds. The time will return me in milliseconds. I want to convert it into seconds, and I'm just going to write seconds in front of that. Now, this is not the correct or right way of, checking the performance of any function or any code. See, this can vary machine to machine. It depends on your machine configuration also, but this can give us an idea, right? At least we can see whether the program is performant or not. But this is not the ideal solution. I just want to be mindful about that. This is not an ideal solution. This is just a way of, indicating, and I mean this will act as an indicator, right? So that we can categorize our solution into any of one of the category from here. Okay, so now I'm going to copy this same code, from here to here also. So I did a mistake here. So I was copying the mistake also. So let me just, okay, let's do this. I mean, I have copied my code before copying, or maybe I'll just keep it copied. First of all, I'm going to run this code. Okay, so this is my problem statement number one, solution number one, implementation number one with the for loop, right? And I have given the input as 10. So I'm going to clear it and run the program. And you see that it's taking just 0 seconds, right? Once again, I have ran it and it took 0 seconds. I'm going to copy, before copying and pasting, maybe like this is first solution, right? Yes. I'll increase the input value. Okay, let's go with the larger value, maybe like 1000. Still, it is taking 0 to 0 seconds. Let's go with 1 lakh. Still the same time, right? Under 0 second. Maybe I'll go with a larger value now. Maybe I'll use 9 zeros. Okay, so it's 1, 2, 3, 4, 5, 6, 7, 8. Let's start with 8 zeros. Okay. Now you see the time, right? With 8 zeros. Now I'm going to use 9 zeros, save. And now it is taking some time. Okay. So it took around 3 seconds to, produce the output. So something is happening inside this loop, right? Because I'm using a for loop, right? And it's looping one by one. That's why, I mean, loop is nothing but, you're pushing, you're putting efforts into your program, right? The code is not meditating, basically. I call it a meditation. If the code is very performant, right, I call it a meditating code. But in this case, it's putting a lot of effort to come up with the output. Let's copy and paste this one from here to second program, and let's see what happens here. And I'm not going to go with the larger value. I'll start with small values. Okay, let's start with 1000. See that it's taking 0 seconds. Let's increase it to 1 lakh. Still taking 0 seconds, right? And let's go with that larger value where I had 8 zeros, right? 1, 2, 3. So 8 zeros. Now I'm going to run this program. See that? Still taking 0 seconds. Let's increase this value more. Maybe I'll add more zeros, right? Let's try this. Still taking 0 seconds, right? I mean, this is such a large value, and if I try to put it here, probably this code is not going to run for 30 seconds, 40 seconds, or a minute, maybe more than that. So you see, right? I have multiple solutions to one problem statement. Add up to number one was using a for loop, and another solution which is using just a formula. You can Google this formula, right? And as I am increasing the input value, this second solution is so performant. It's always, I mean, it's returning the output in constant time. But in case of program one, implementation one, basically, as I increase the input, its output time is also getting increased. So this is what this comparison, I just wanted to give it to you because this is really important, right? How you can justify when we do a comparison between two different two different implementations, right? So implementation one and implementation two. That is the reason. I mean, this BIGO is created, right? Just to have justification about your code, whether your code is scalable or not, and scalable in terms of time and space. So I'm just going to quickly recap this. So we talked about programming, right? Programming is all about computer programs are all about collection of data and function. Then we talked about a problem statement where we can have multiple solutions and how we can decide whether which solution is the best solution, right? And we discussed, right? The BIGO is going to help us with that, right? And we can decide, we can justify whether this code is a scalable code or not in terms of time and space. So given an input, how much time that function is taking to produce the output, and while that function, that implementation is running, right? How much space that implementation is taking, and based on that, we can rate our function, our program to all of these different categories like excellent, good, fair, bad, horrible, right? So this is why BIGO is important, and this is why product companies, the big companies, the giant companies, they care about BIGO, because when we talk about data structures and algorithm, BIGO is going to come up in picture again and again. That's why I wanted to start this video with introduction to BIGO, why BIGO is important, and I'm going to continue this series in the next videos where we're going to learn about data structures and algorithms so that you can crack the product-based companies interviews. So with that, I'm going to take a pause here. I'm going to stop. This is it for this video. I'm going to see you in the next video. Until then, you take care and goodbye.